Okay, so in this video, our focus will be on the turning point, x and y-intercept of a quadratic function. All right, so when we talk about the turning point, we are simply referring to this point right here. This is a turning point. So the graph is coming like this, it makes a turn. So where a graph is making a turn is what we call the turning point. When we talk about y-intercept, we're simply talking about this point where the graph is passing or cutting the y-axis. And when we talk about the x-intercepts, so for the x-intercepts, we're talking about the point where the graph is cutting the x-axis. It's right here and here. Okay. If we have a 4 here and a 1 here as x-axis, we have a 4 right here and a 1 here, we can say these two are the solutions. So we can say the solution of this, or solutions of this graph right here, or this function, will be x is equal to 1 and x is equal to 2. So we have these two solutions. So that's how it works. We can look at this other one. This also has got the x-intercept right here and here. We have x-intercepts here and here. And the turning point is right here. At the turning point, that's where the y-intercept is for this graph. Okay? So that's it. Let's try to do an example. So example number 1 right here. The example reads, for a parabola with equation y is equal to 2 minus x squared, find the y-intercept, that's A, B, x-intercept, and the coordinates of the turning point. So when you have a question like this, it is very important you graph it. If you so wish, you can use a graph. If you don't want to use a graph, you can simply say, you get your equation or the function y is equal to 2 minus x squared. So this is what we've been given here. We start with the turning the y-intercept, because the question here, the first question says we find the y-intercept. So for the y-intercept, we'll simply say let x be equal to 0. This is the procedure. So let x be equal to 0. We want to know at which point is this function cutting the y-axis. So since it's the y-axis that we want to find where it's cutting, we will say x is equal to 0. So when x is equal to 0, we have a 2 minus, right here we have a 0 where x is, minus another 0 and the power 2. Okay, so from this point we can say y is equal to 2 minus 0 minus 0 squared. It will just be a 2. So this is the solution for question A, and we can say our y-intercept is equal to 2. Question B, right here, we find the x-intercept. So this is question 1. Question A, where we were asked to find a y-intercept. So now for the x-intercept, we get our function right here. Okay. Now we let y is equal to 0. The reason why we are letting y is equal to 0 is because we want to find at which point is this function cutting the x-axis. So for the y-axis will be equal to 0. So we can say 0, we put a 0 here, is equal to 2 minus x squared. So this is a quadratic equation. Do we know how to solve a quadratic equation? I guess so. We know how to solve quadratic equations. If you don't know, you can review or you can check my previous video on quadratic equations. So this will be a 0 is equal to, we have a 2 here. Here we find factors, two numbers such that when you multiply them, they give us -2, and when we add them, they give us a 1. That is a -2 and a 1. So we write, now we can factorize by grouping. So we just say this and this. So there we have a 0 will be equal to 2 outside, you remain with 1 minus x. Here, x outside will remain with the 1 minus x right here. Okay. Our next thing here will just be to equate or to pick to get this stuff plus this stuff right here. So we have something like this. So this is what we have. From here we can say our x will be equal to -2, or x will be equal to 1. So these are the 2 points at which the graph is passing through the x-axis. Okay, so we can say this is our x-intercept and this one. If you don't know how to solve quadratic equations, kindly check my video. I'll put the link in the description so that you can just click on it and it will take you right there where the equation or the idea of solving quadratic equations is. All right, so we have answered question B. We can now go to question C, where we are asked to find the coordinates of the turning point. So this one, coordinates of the turning point. So to find the coordinates of the turning point, we need to use the formulas. There are 2 formulas. So we need to find the x coordinate. We need to find the x coordinate and the y coordinate. Good. So we need this, and we also need this. So now for the x coordinate, we have a formula which looks like this. Remember, I said the turning point is here where the curve is making a turn, and x-intercept is the point where the curve is passing through the x-axis. There are actually 2 points here, and the y-intercept is the point where it's cutting the y-axis. So in this example, we have found the y-intercept, x-intercepts, and now we are remaining with the coordinates of the turning point. So the formula is right here, and we know the given equation or function looks like this. Y is equal to 2 minus x minus x squared. This is the function we've been given in the question. So what we're going to do here is just to identify. If you know the standard form of the quadratic function, this is our a, is right here, and b, c is over here. How do we get to know that this is our a? Where there is power 2 is our a, where there is just x here is our b, where there is a constant, a number without a letter, is our c. So now we can plug in. We have negative, our b there, it's -1, over our a is -1. So a right here is -1, b is also -1. So we can solve. We have 1 over -2 here, of which we can just write it like this. Okay? So this is our x coordinate. Now for our y coordinate, the formula is also different, is a little bit different from this one. So the formula for our y coordinate looks like this. So you need to know these two formulas if you want to be finding the turning point. So that's this is our formula. So from there, the function there, we can identify our a. What is our a? We know it's -1. Our c is 2. Our b is -1 also. Our a there, we know it's -1. So we do our calculations. This will give us -8 when you multiply, minus 1, because here there is power 2, which makes this one positive, and then there is a minus in between. Here we have -4. We have -9 over -4 right here. So we work out nicely, we find our answer to be equal to positive what? Because this and this will disappear, positive 2 remainder 1 over 4. So this is our y-axis. So you can say y-axis, y coordinate, and our x coordinate right here. So the coordinates, we can write them as -1 over 2, 2 remainder 1 over 4. So this is our solution. Now if you want to put this, okay, we want to put this on our graph, we can do this. We can say, okay, what was our y-intercept? Our y-intercept was right here, which is 2. So our y-intercept is 2. So our graph is passing at point 2. What is our x-intercept? Our x-intercept was -2 and 1. So 1 right here, -2 is right here. We go to our turning point. What is our turning point? Turning point, we just found right here the coordinates of the turning point. We found -1 over 2, 2 remainder 1 over 4, of which it will just be, because this is half, 1 over -1 over 2 is half, it's somewhere here, and 2 is right here, remainder 1 over 2, so it's somewhere here, right here. This is where the point is. So we can join these points. We have a graph which looks like that. So this is our graph. So example number 2 right here. Hopefully you're able to see. The question reads, the diagram below shows the graph of y is equal to -x plus 2 inside the brackets, x minus 5 inside the brackets. The graph cuts the x-axis at A. So where is A? A is right here, and B is over here. And then the question reads, Find the coordinates of the points A and B. Question 2, maximum value of y. So we'll start with the question 1 there. So question 1 here is very simple. They want us to find the coordinates, the points A and B. So how do we find the coordinates of these 2 points? A is over here and B is here. So what we can do here is just to say y is equal to, after copying this function, we will just let x, okay, is equal to 0. In short, if you want to find where it's passing here at x, we just say this is the x-intercept. So for x-intercept, we say y is equal to 0, not x. Y be equal to 0. So write our 0 where y is, and here we have something like this. We solve for x. So how do you solve there? We just equate. We say, okay, or 0 is equal to x minus 5. We just equate. What is here is equal to 0 and what is here is equal to 0. So when we solve, group the like terms, you find that our x will be equal to 2. And here our x will also be equal to 5. So now, since our y is 0, for the coordinates here, we can say A, because A, here where B is, it's bigger than, or it's a bigger number. That's the bigger number of x, which is supposed to be here. And for A, it's a smaller number of x. So in this case, we have these 2 numbers. Which one is big? This one is big, which means 5 will go at point B and 2 will go at point 2. So we can say at point A, our x coordinate is 2 and our y coordinate is 0 there. At point B, our x coordinate is 5, our y is 0. So these are the 2 points at which the graph is cutting the x-axis. So we're done with this question. We go to question 2, where they want us to find the maximum value of y. So the maximum value of y, it's simply the turning point. Now the y value here at the turning point. What is the y value at the turning point? Remember, I showed you the formula to use when you want to find the turning point. There are 2 formulas for finding the x value and the y value. So since it's y that we're dealing with, we're finding the maximum value of y. So we will just use the formula for finding the turning point, or the value, the y value at the turning point, which is equal to y is equal to 4a c minus b squared over 4a. This is the formula we have to use. Now, when we look at our function here, is it in order? No, it's not. So we can put this function in order by saying y is equal to, we just must multiply, distribute. This times this will give us negative x squared. This by this, positive 5. This by this, positive 2x minus 10. Okay, so let me write my function properly so that you can be able to see it nicely. We have something like this, and here we can work out things. We have actually here it's positive. We have something like this. When we add 5x plus 2x, it will give us 7x. So it's now in standard form. This is what we need right here. It's in standard form. So since it's in standard form, we can now plug in 4 our A, we know that this is the A right here, B is here, and C is right here. So for our A there is -1, our C is -10, our B is 7 power 2 there. Here, so let me cut here. Here over 4, our A is -1. We solve, we have 40 minus 49 over -4. We solve here, we have -9 over -4, of which will remain with something like this, because negative and negative will disappear. We can say this is the maximum value of y. We're done with that one. We can check our last example, example number 3 over here. So this is our example number 3. So for example number 3 there, we have been given that stuff, and okay, let me just read. A function y is equal to 1 plus x inside the brackets, x minus 2 inside the brackets. Question 1. Sketch the graph of the function in the answer spaces below to find the minimum value of y. So how do we sketch that one? So in order for us to sketch, we first need to find what we call the x-intercept and the y-intercept. Okay, x-intercept and the y-intercept. All right, so for the x-intercept, okay, so for the x-intercept here, we will say let me say x-intercept we will say let y be equal to 0. So in our function here, where y is, we put a 0. So we have something like this. So this is what we have. We can equate this to 0. So we have 1 plus x is equal to 0, or x minus 2 will be equal to 0. So we just equate to whatever we have inside here equal to 0. So our x will be equal to -1. When you group like terms, this one will cross the equal sign, it will be -1. And our y here will be +1. So we have the coordinates right here. -1, 0, and 2, 0. So we have these two sets of coordinates. Very important to come and use them. We also find the y-intercept. So we say y-intercept. So for the y-intercept, we will let x be equal to 0. Our function is y is equal to 1 plus x. Here it's like this. So now, since we are letting x is equal to 0, we have y is equal to 1 minus plus 0, 0 minus 2. So we can solve there. We have a 1, we have a -2. When we solve nicely, we have a -2. Okay, so the coordinates will be 0, this one from x, comma -2 right here. So we have 3 things. We have the coordinates of one point of x, another point of x, and the point of y. So the last part that we need is to find the turning point, or coordinates of the turning point. So for the coordinates of the turning point, we will get the given function, which is y is equal to 1 plus x inside the brackets, x minus 2 inside the brackets. So here we'll put this function in standard form. So we'll start multiplying what is here, this by this, this by this, this by this, we have this by this, we have something like this. We can group the like terms. X squared plus x minus 2x minus 2. Y is equal to x squared minus x minus 2. Okay, so now it's in standard form. Remember the formula for finding coordinates of the turning point. So x-axis is like this, okay, and y-axis is like this. Okay, so for x-axis we can say what is our a is 1, our b is -1. For our a is 1. This one will be something like this. Okay, that's it. Yeah, this is how it will look like. It will be 1/4. Is it what we have? Sorry, actually here it's supposed to be 2. I've made a mistake. We're supposed to have a 2 and a 2 here. Okay, so it's supposed to be half. It's supposed to be 1/2. Here you have 4. A is 1. C is -2. Minus B is -1. Here we have 4. Our A is 1. So we can work out things. We have -8 minus 1/4. And here we have something like this, of which we can say this is the same as this. So the coordinates here will be half, here this. Okay, so we have this, very important. So now we can graph. So our graph will look like this. Okay, we do the Cartesian plane there. So we have 1, 2, 3. So this is 1, 2, 3. This is 1, 2, 3. -1, -2, -3. 1, 2, 3. 1, 2, 3. So the coordinates, remember, for x-intercept, it's passing at -1 right here, comma 0, and at 2, 0, it's right here. Y-intercept, we found -0, -2. So -2 is right here. So it's here. And then for the turning point, we found 1 at 2. It's 1/2. 1/2, which is half. This is 1. If 1 is here, 1/2 must be somewhere here. And 2, this 1/2, -2, remainder 1/4. It's supposed to be somewhere. So the point must be somewhere here. And the graph, when you do it, it will look like that. And then for question 2, where they are saying find the maximum, the minimum value of y. So for the minimum y the minimum value of y will just be -2 remainder 1/4. It will just be this stuff here. We've already calculated from the turning point. You just get the y value from the turning point. That's all. Thank you so much for watching my video. Kindly subscribe to my YouTube channel, and for online tuitions, the number is here. If you are interested to do online tuitions with us, the number is right here, 0969175701. This is the number. You can WhatsApp us and ask more about the procedures on how you can join the online tuitions. Thank you. Bye-bye.